Welcome to AI Explains. You know, in the hard sciences, there's this pervasive feeling called physics envy.
Oh yeah, it's a very real thing.
Right. It's this deep-seated jealousy other scientists feel because physics has these beautiful, elegant equations like E equals mc squared, you get three letters, and you've basically explained the universe.
It is the ultimate standard of elegance. I mean, it really is. But when you move away from gravity and particles into human fields like language or economics, things get messy fast.
Mhm.
Humans are unpredictable. We just don't follow clean mathematical laws.
And that messiness is the launch pad for today's deep dive. So we're going to break this down in simple terms as if you are completely unfamiliar with the field. We're looking at a seminal paper called The Unreasonable Effectiveness of Data.
Right. Written by Google researchers Alon, Halevy, Peter Norvig, and Fernando Pereira.
Exactly. And it's essentially a manifesto arguing that this physics envy is actually holding AI back.
Yeah, they make a really counterintuitive argument here. In the AI world, having more data, even if it's messy, broken, and completely unpolished, is almost always better than having smarter algorithms.
Which feels wrong, we're always taught garbage in, garbage out.
Totally. But they point out that trying to program the rules of language is a complete trap. They
Mhm.
mention that a standard English grammar book runs over 1,700 pages, and it's still incomplete.
Because language is infinite.
Exactly. It changes every single day. If you try to hand code every rule, you're never going to finish. So the paper argues we should rely on volume instead.
And they prove this by comparing two famous data sets. First, you've got the Brown corpus, which for a long time was the gold standard. 1 million words of carefully checked, linguist-approved text. It was pristine.
Yeah, but compare that to what Google released in 2006. That was 1 trillion words scraped right off the open web.
And strictly speaking, the Google data was terrible. I mean, spelling errors, half-finished sentences, bad grammar.
Oh, absolutely awful data. But the dirty Google data set completely outperformed the clean one.
Because of coverage.
Right. It was 1 million times larger, so it captured the long tail of language. Rare phrasing, slang, weird context that the tiny clean data set just missed entirely.
And this leads to what they call the simple model principle. The idea that simple mathematical models plus huge amounts of data will beat out complex, quote-unquote, smart models that only have small data.
Translation is the classic example of this. We used to try to teach computers French grammar, subject, verb, agreement, and it just didn't work. Modern translation works by memorizing massive amounts of phrases, or n-grams.
And just to clarify for everyone listening, an n-gram is really just a fancy way of saying a sequence of words.
Right, it's pure probability.
Yeah.
The computer doesn't know why maison and blue go together. It just sees that sequence enough times to calculate that blue house is the likely translation.
Right.
It's not understanding, it's statistics.
There's a great visual example in the source that really lands this. It's about scene completion. So say you want to Photoshop an ex-spouse out of a picture, and you need the computer to fill the background.
If you train an AI on just 10,000 photos, it tries to mathematically guess what goes in that hole. And it usually looks blurry and fake, right? Because it's inventing pixels.
But if you train it on millions of photos,
It stops guessing and starts searching. It finds a patch of grass or pavement from a totally different image that statistically fits the hole perfectly.
it fills the gap seamlessly.
Exactly. It's not magic, it's just volume. The answer is already in the data, you just need enough data to find it.
And this shift from rules to volume changes how we organize information online. Like the old idea of the semantic web, where we were supposed to label all our data perfectly so computers could read it.
Which was totally a pipe dream. I mean, it's way too expensive and difficult to enforce. The authors argue for semantic interpretation instead.
Right. Basically, let the web be the Wild West and build AI that just figures it out.
Take data tables, for example. The web is full of messy tables. If an AI sees the letters HP in a column, it doesn't know if that means Hewlett-Packard or the oil driller Helmerich and Payne.
Right. And a rule-based system gets completely stuck there.
Yeah, it needs a human to label it. But a data-driven system looks at the context. It sees stock price in the next column, or Dell in the row above, and statistically determines HP must mean the tech company. It learns the concept without us ever teaching it the rule.
That is the core takeaway. The unreasonable effectiveness comes from letting go of elegant rules. We aren't teaching computers how to think, we're just giving them enough memories to fake it.
Which brings up a really interesting point.
Yeah, a final provocative thought to leave you with today. If AI intelligence is mostly just memorizing billions of tiny fragments of human behavior rather than understanding any actual rules,
Is the AI actually smart?
or is it just a giant mirror reflecting our own collective output right back at us?
That really is the question.